There's a question about the carbonyl group, whether it can exhibit dipole-dipole interaction or because it has significant dipole moment. It can, at the same time, it can also form hydrogen bonding. So you're confused about which one is more significant and important for binding. So if you see dipole-dipole interaction, there is a dipole moment. The carbonyl group can actually exhibit the dipole moment. If you have also, if a drug is approaching a binding site, active site, for example, and one of the binding site has got a localized dipole moment, so the carbonyl group of a drug can then orientate itself so that the positive charge will interact with the negatively charged here, and the negatively charged on the negative dipole can interact with the positive dipole of the on the binding. Similarly goes for if a particular carboxylate and also a carbonyl. So here in this case, you have carbonyl group on a drug, and then there's a carboxylate group. Yeah, for example, that is basically a carboxylate group of an amino acid. So in here, what happens is that again, the carbonyl group will reorient itself so that the interaction occurs between the opposite charges of the dipoles. It can also happen, another scenario that can happen whereby you have this induced dipole interaction, whereby the primary amine, the charge, approaching a hydrophobic binding site in a receptor or enzyme, it can actually induce a dipole moment, meaning that if it is positive, now if the amino group is positively charged, it will induce that because of the pi-pi interaction, it is actually also electron rich. So the one side of the is facing the approaching ammonium ion, would give the negative dipole, whereas the other side of the aromatic ring will give a positive dipole. So if you have a look, coming back to the question, yes, carbonyl group can actually also have both dipole-dipole interaction and also hydrogen bonding. Which one will predominate is in terms of you see van der Waals interaction, or I say flirting with the target, which you normally have quite a weak interaction, in terms of the strength, it's about 2 to 4 kilojoule mole, and the strength of this dipole-dipole moment and also the van der Waals, in general, would diminish with distance. So a drug is away from the binding site, for example, the much weaker the interaction. Now, if you compare that to the hydrogen bonding, it is actually about 10 times weaker than a covalent. Sometimes it's considered as a weak electrostatic interaction. It's considered that way. So it's if you see it in terms of the strength, depending on how much is overlapping with the in terms of the orbital, the strength is about 16 to 60 kilojoule per mole. So in one sense, it's actually about 4 to about 40 times more than van der Waals or even dipole-dipole moments. So most of the interaction between a drug or even substrates with its receptors or enzymes or proteins would actually involve hydrogen, usually most of the time. And similarly with van der Waals or dipole-dipole, hydrogen bonding will also reduce in its strength as it's away from the binding site.